Welcome back to D-Machine, the place where we explore the craftsmanship, the engineering, and the forgotten skills that built the modern world. Today, we're stepping into a factory that produces something few people ever think about, yet every ship on the ocean depends on it for survival. The anchor chain. These massive steel links carry the weight of entire vessels, holding them steady through storms, tides, and years of saltwater corrosion. Behind each chain lies a process shaped by history, forged from old-world metalworking, perfected by modern machinery, and tested to standards that leave no room for failure. In this video, we'll follow the entire journey, from raw steel bars to glowing red-hot links, to precision welding, heat treatment, testing, and final protective coating. You're about to see how one of the strongest pieces of hardware in the maritime world is brought to life. Let's begin. Every anchor chain begins with solid, high-strength steel bars, heavy, dense, and forged to meet strict maritime standards. These bars may look simple, but each one will eventually carry the weight of an entire vessel as it battles wind, waves, and open ocean forces. Workers sort and select the bars according to the exact diameter required for the chain being produced. Then, the bundles are moved to a heavy-duty industrial saw. This dual-blade cutting machine works with remarkable precision. Even a small deviation, just a few millimeters, can weaken a link later during forging and welding. As the saw cuts through the steel, metal chips spray out like silver dust, and the bar heats under the steady rhythm of the blade. Each piece is cut to the exact length needed to form a single link. It's a foundational step. The strength of an anchor chain doesn't begin at the ocean floor. It begins right here, with these simple steel bars. Once the steel bars are cut down to size, they move into the first real transformation stage. The small cylinders are fed into a rotary loader, and from here they travel into an induction furnace. Within seconds, the steel reaches temperatures above 1,000 degrees Celsius, glowing bright orange, soft enough to shape, but still incredibly dense. At this point, each piece is sent into a forging press. The machine delivers tons of pressure in a single strike, squeezing the heated steel into a distinctive shape. These flared ends might look unusual now, but later, they will become the curves and shoulders of a finished chain link. Fresh from the press, the pieces are still blazing hot, falling into bins like chunks of molten ember. Once cooled, They reveal a rugged, hammer-forged texture, evidence of the immense force that shaped them. This step sets the geometry of every link. Before a chain can be bent, welded, or tested, its ends must first be forged with precision, because the strength of the entire chain depends on how well each of these pieces takes shape under fire. After the forged end pieces are prepared, the long steel bars are carried forward for the next major transformation. They enter an induction heating line, where powerful electromagnetic coils raise the temperature of the steel to nearly 600 degrees Celsius. As the bar glows bright orange, it becomes soft enough to bend, yet still strong enough to hold its structure. From here, the glowing bar moves straight into the bending machine. Heavy rollers grip the steel and begin shaping it into a tight, smooth curve. First, the machine forms a clean U-shape. Then, in a synchronized motion, additional rollers press and guide the bar until it closes into the familiar outline of a chain link. It is a remarkable process to watch. Raw steel, once rigid and unyielding, turning almost fluid under heat and pressure. Every link must be bent with perfect precision. If the curve is too tight, the metal weakens. Too loose, and the chain will fail under load. This stage gives the anchor chain its true identity. For the first time, the steel bar begins to look like the links that will hold ships steady against the power of the sea. Once each glowing steel bar has been bent into the shape of a link, there is still a critical gap left at the joint. That small opening is where the real strength of the chain will be decided. To close it, the unfinished link is moved to a towering welding station, an automatic flash butt welder built to handle metal weighing hundreds of pounds. Workers position the link, and the machine brings the two ends together. A surge of low voltage, high current electricity passes through the steel, instantly heating the joint to a near molten state. Sparks erupt as the metal softens, and then, in a split second, hydraulic rams drive the ends together, forging a solid, seamless bond. Next, the still hot link is pressed between shaping dies. This step smooths the surface, removes excess material, and ensures that every link matches precise maritime standards. Even the stud, the bar across the center of the link, is pressed firmly into place, locking it into the structure so it can resist twisting and deformation under load. When the forged link drops to the floor, it carries the unmistakable look of raw strength, heavy, solid, and uniform in shape. One more piece ready to become part of a chain built to hold ships steady against the open sea. After the basic link has been fully forged and welded shut, there's still one critical feature missing: the stud that runs across the center of the link. This simple-looking bar plays an essential role. It prevents the link from collapsing under load, stops twisting, and ensures the chain holds its shape when forces surge through it. Inside the stud welding zone, the long rows of freshly made links are laid out to cool naturally. Once they reach the right temperature, workers begin welding the stud into each link by hand. Bright arcs of light flash across the floor as welders fuse the stud to the body of the link, locking it firmly into place. Up close, the metal glows from the intense heat of the weld. Every connection must be uniform and strong. Any weakness here could compromise the entire chain. When the welding is complete, the links reveal their final form: solid steel frames with a reinforced spine running through the middle. It's a slow, meticulous step, one that combines human skill with industrial precision. And it's what gives an anchor chain the internal strength to survive years of punishment on the open sea. Once every link has been forged, welded, and reinforced, the chain is still far from ready for the sea. To survive the constant shock loads of waves, anchors, and shifting currents, the steel must be hardened, then softened through a precise heat treatment process. The finished chain is lifted into a vertical, continuous furnace, controlled entirely by computer. Inside, multiple heating zones raise the temperature of the steel to over 900 degrees Celsius. At this temperature, the structure of the metal changes, becoming capable of far greater strength. From the furnace, the glowing chain is lowered straight into a quench tank. As the steel hits the cooling medium, a burst of steam erupts. This rapid cooling locks the metal's new hardness into place. But hardness alone isn't enough. Steel that is too hard becomes brittle, dangerous for something that must hold thousands of tons in harsh ocean conditions. That's why the chain is reheated again, this time to around 600 degrees Celsius. This tempering step relieves internal stresses, increases toughness, and improves resistance to wear and impact. When the chain emerges, it carries a deeper, more rugged texture. Stronger, tougher, and ready for the punishing life it will face offshore. This is the moment when raw steel truly becomes an anchor chain. After heat treatment, the chain may look complete, but its strength is still only a promise. To earn its place on a ship, every single link must survive a test that pushes it to the edge of its limits. In a long testing bay, the chain is fed into a massive proof-loading machine, some capable of applying more than 1,600 tons of pulling force. As the chain tightens, the steel groans, the rig shakes, and every weld, every bend, every stud is challenged at once. High-precision sensors monitor the load in real time. The machine stretches the chain to ensure it meets strict dimensional standards. 5-link length, stud alignment, and ovality must all fall within exact tolerances. On the control screen, technicians watch both ends of the chain through live cameras, checking for even the smallest sign of deformation. If a link fails here, it will never leave the factory. But if it holds, if the steel withstands forces far greater than it will ever experience at sea, then the chain is certified, ready for the unforgiving conditions of deep water anchoring. When the test is complete and the tension is released, the chain falls back to the floor with a heavy, confident thud, proof that it's earned its strength. Even after the chain has passed its strength test, one final stage remains: finishing and inspection. This is where every link is prepared not just to be strong, but to stay strong for years of harsh service at sea. The chain enters the shot blasting zone, where thousands of steel pellets strike its surface at high speed. This process removes scale, rust, and oxidation left from forging and heat treatment. When it comes out the other side, the chain has a clean, matte finish, perfect for coatings and far less likely to corrode. Workers then inspect every weld by hand. Grinding wheels smooth out rough edges, ensuring no sharp points can start cracks under load. After that, the links undergo non-destructive testing. Magnetic particle inspections reveal hidden surface flaws. Ultrasonic probes search deep inside the metal for internal cracks that the eye can't see. Technicians study the readings carefully. If a link shows even the smallest irregularity, it's removed from the line. Only the links that pass every test, mechanical, visual, and structural, are approved for shipping. When the inspection is complete, the chain lies ready on the factory floor, clean, tested, and proven, built to withstand decades of saltwater, storms, and the relentless pull of the open ocean. Before the chain is cleared for delivery, one more layer of assurance is added: verification and protection. In the testing lab, technicians take samples from each production batch. These small pieces of steel are clamped inside a precision tensile testing machine. As the computer applies force, the screen shows the steel's yield strength, elongation, and ultimate breaking point. These numbers confirm whether the material meets international anchor chain standards, because a single weak batch could jeopardize an entire vessel. Once the material is certified, the finished chain moves on to the coating process. Workers lift entire sections using heavy hooks and lower them into a large protective bath. Depending on customer requirements, the chain may receive black paint, oil-based coatings, or specialized anti-corrosion treatments. The coating seeps deep into every curve of every link. This layer shields the chain from rust, seawater, and decades of abrasion on the ocean floor. When the chain is raised from the tank, it shines with a thick, glossy finish. Its final armor, ready to face years of storms, tidal forces, and the unforgiving salt of open seas. With this final step, the chain becomes complete, tested, protected, and built to last.